No big intro today, just to say that a student kindly requested that I do a quant walkthrough, and so this is another one of those McGraw-Hill GRE practice tests. I'm going to do one full quant section. I haven't seen the questions before, so let's get straight into it. Of course, I might get loads of these wrong, but you'll see that live. Okay, a squared minus b squared equals 1, so I would straight away factorize that as a plus b brackets a minus b equals 1. Now, does that tell us whether a is bigger or b is bigger? Not sure. The factorizing didn't really help, so I'd be thinking of picking numbers. Now, that would say that it would say that a is a bigger number, but it could be negative or positive, right? So for example, a could be square root of 2 and b could be 1. So when you square the square root of 2, you get 2. 2 minus 1 equals 1. But a could also be minus the square root of 2. So even though it looks like a would be bigger, because the difference between a squared and b squared is 1, making a bigger, a could be a bigger negative. And so we actually don't know the relationship. Always think about negative numbers. Okay, next one. I know I'm teaching at the same time, but I can't help it. In diagram 1, the sum of the diameters of the two smaller circles is equivalent to the diameter of the larger circle. The circumference of the larger circle, the sum of the circumferences. I think I would already know that they're going to be equal, but I will quickly check. So for example, if the diameter of the first circle on the left is 2 and the other little circle is 1, that would mean that the diameter of the bigger circle is 3. So using the formula for circumference of a circle, which is pi times d, that would give us 2 pi for that first circle, 1 pi for the second circle, and that does equal 3 pi for the larger circle. So I picked numbers to prove my point, but I think I knew that already. Okay, picking numbers help there. Of course, you need to know the formula for the circumference of a circle. Okay, this one, x cubed is bigger than x to the power of 5. Let's give myself a new page. Okay, always think about the golden set of numbers. Is that true for a positive integer, like 2? No, it's not true. Is it true for a fraction, like a half? Yes, a half cubed is an eighth, and a half to the power of 5 is 1 over 32, and an eighth is bigger than 1 over 32. So it's true for a positive fraction. But is it true for a negative fraction, like minus a half? Well, you get minus an eighth and minus 1 over 32. And actually minus 1 over 32 is closer to 0 and therefore is bigger. So it doesn't work there. Finally, let's try negative integers. That's the last member of the golden set, giving us negative 8 here and negative 32. And negative 8 is bigger than negative 32. So as I thought, it's 2 of the categories of the golden set. Therefore, we don't know whether x is bigger than 0 because it could be a positive fraction or a negative integer. That's a quick demonstration of the golden set. Don't think I've done a video on it, but it's very, very useful set of numbers to test in this sort of situation. So the answer would be D. Hope this is helping. Okay, new page. B squared C is less than 0. Well, looking at that straight away, we know B squared is going to be positive or 0. But it can't be 0 because it says less than 0. So b squared is positive, meaning c would have to be the one that's negative. Because a positive, b squared, times a negative is the only way to get a negative. So we know c is less than 0 from the first statement. From the second statement, a, b, c is greater than 0. Well, using the first statement, we know that c is negative, meaning that a, b together must be negative. Why? Because a negative times a negative gets you the positive, and we know that c is negative. So we know AB must be negative. Answering the question, AB is going to be smaller than 0 because AB is negative. Obviously, I'm going really fast here, but I'm kind of demonstrating how fast you need to go to get a perfect score. Obviously, in my teaching videos, I go a lot slower than this. Okay, this question. The probability that a certain event will occur is X. The probability that an event will not occur is Y. Well, if the probability that a certain event will occur is X, the probability that it won't occur is 1 minus X. Right, so they're basically telling you that 1 minus x equals y, because they said the probability that the event will not occur, which we know is 1 minus x, is y, equals y. So there's a little equation that we can create. Plugging that into quantity A, we get x plus y, but we know that y is 1 minus x. So that gives us x plus 1 minus x, and the x's cancel, giving us 1, so both quantities are equal. All of that just came down to knowing that if the probability of something occurring is x, then it not occurring will be 1 minus x, essentially, because it always has to add up to 1. Brilliant. Okay, so n and q are positive integers, and n is a multiple of 5. Quantity A is q to the power of n minus 5, and quantity B is q to the power of n over 5. Interesting. I'm not quite sure where they're going with this. Well, let's pick numbers, okay? Well, actually, if we pick numbers... Okay, let's quickly do that. So let's say q is 2. So 2 to the power of... And if n is 5, because that's the first multiple of 5, q to the power of 5 minus 5, and q to the power of 5 over 5. 5 minus 5 is 0, 2 to the power of 0 is 1, 2 to the power of 1 is 2. So in this case, quantity B is bigger. But I've just noticed something. It said q is a positive integer. That means q could also be 1. And what do we know about 1? 1 to the power of anything is always 1. So no matter what I picked for n, I could pick a billion or minus a billion. I know that's not allowed, but anything I pick will always give me the answer of 1. So the quantities could also be equal. But I've already proved for my first set of numbers that the quantities might be different. So therefore the answer is D. Taking a big shortcut there, just by knowing the fact that if q is 1, which is allowed, then the power doesn't matter. The answer will always be 1. Okay, next one. This is fun. The measure of angle ABC, so that's the one at the top, and the measure of angle DEF, that's the one at the top. Now clearly the sides are just double. You've got 5 become 10, 9 become 18, 13 become 26. So I probably should get this a bit quicker, but they're similar triangles, right? It's just everything's just been doubled. And if they're similar triangles, they have the same angles, and therefore the two angles are going to be equal. Now I'm being really slow here, but I just want to double check that. Are they definitely similar triangles? If all the sides are in proportion, yeah, it's just been times by 2, and therefore they're similar triangles. I don't know if I've done a video on similar triangles. I should check out if I have. But yeah, quick bit of knowledge about similar triangles there, all the angles being equal. This one, the retail price of a bookshelf is $Y. The retailer will either add 5 to the retail price and then mark the price down by Z%, or will mark the price down by Z% and then add 5. And the question is the price of the bookshelf after they add 5 and then mark down versus if they mark down and then add 5. Great question. Well, it depends, doesn't it? Because they're mixing up a percentage with an actual amount of $5. So obviously this is going to be a picking numbers kind of approach. But I just want to get my suspicion out there already, which is that the answer is going to be D, because they're mixing up Z% with 5 actual dollars, which is not a percent. So how could we ever know? For example, if Z is like 99%, basically eliminating the price, watch what happens. Okay, and say we start off at $100. If we add 5, if we add 5 in quantity A to $100, we get 105. Mark it down by 99%, the price is now like $1 or something, hardly anything. But look what happens with quantity B. If it's marked down by 99%, it goes down to $1 from 100. Then we add 5, we get to $6. So quantity B would be way bigger in that instance. Obviously, I just picked some crazy numbers there, some extreme values, which you might notice from other videos. It just helps me elucidate that it's going to depend on what Z is. Now, obviously, I've just created an example where quantity B ends up being bigger. The question is, can I do one where quantity A ends up being bigger? What if Z is 0%? Adds 5, but then the two quantities would be equal, right? If Z is 0, you add 5 and then mark it down by 0. So that would be 105. But if they mark it down by 0, as in it doesn't change at all, and then add 5, it's 105. So surely the answer has to be D, because they never said that Z had to be a positive number. So I'm pretty convinced. This is the type of question I might spend an extra minute on the test, just to sort of confirm. But I'm kind of curious to try out a small number like 10%. I know I'm kind of wasting your time, but I already have proven that it's D by trying 0 and 99. I'm just kind of curious. If we try 10%, okay, well, we add 5, that would be 105. Mark it down by 10%. Let's use a calculator for that, I'm being lazy. 105 times 0.9. That would be 94.5 in quantity A. But if we mark it down by 10% first, that's 90, and then add 5, that's 95, so quantity B is bigger, which gives us a dilemma, because I think we've just proven that no matter what Z is, as long as it's not 0, quantity B always ends up being bigger. Because you notice with 99%, it ended up being bigger, and with 10%, a small number, it ended up being bigger. So the answer would normally be B, but they never said Z might not be 0. So I'm going to pick D because Z might be 0. But if they say the answer is B, it's because they overlooked the fact that Z could actually be 0. That's my conclusion. Okay, next question. This one, classic difference of two squares. We factorize that. The first one is 2a squared, and the second one is 2b squared. Is it to be or not to be? That's the question. I think it is to be. So if we factorize that, we get 2a minus 2b and 2a plus 2b, which is quantity C. I think that formula's come up twice already, right? So it's really good to memorize. In my video, the most important quant formula you need to know. Check it out. If each of the sides of a certain square is doubled in length, by what factor will the area of the square increase? It will get 4 times bigger. This is the LAV principle, which I haven't yet done a video on, but basically if the length is doubled, the area will be that scale factor squared and the volume with that scale factor cubed. So the area will be 4 times bigger. I don't even need to pick numbers for that. On Tuesday, a salesman made 4 sales, good for him or her. On the first 3 sales, the salesman received a commission of those 3. If the salesman's average commission for all 4 sales was $2,000, what was the salesman's commission for the 4th sale? I always tell students, if you're given an average, convert it to a total. So you notice they told us the average for all 4 sales was $2,000. Therefore, multiply that by the number of terms to find the total. I can't count the number of times I've told students to do this. They give you an average, multiply it to find the total. They told us in that second line that the average for all 4 sales was $2,000. Therefore, the total commission is $8,000. We've already got 2,1, 1,5, and 1,8. Could use a calculator, but it's quicker this way. And so we already know that the commission so far is 5,004. So the 4th one must have been 2006. Answer E. Obviously, feel free to use a calculator, but I've taught this average topic many times in many videos. This one, if 2a is less than 6, let's quickly simplify that. So a is less than 3. 3b is greater than 27, so simplify that. So b is greater than 9. Then b minus a can equal all of the following except. Notice they never said integers, so be careful. Don't say a is 2 and don't say b is 10. That's what they want you to do. Because look, if I make that mistake, if I say that a is 2 and b is 10, watch what happens. B minus A is 8. And so people go, oh, it could be 8 or 7 or 6. And then they pick those answers and they get it wrong. So don't make that mistake. A is less than 3 and B is greater than 9. Pick the borderline values. It's really important. Don't pick the one integer below because they never said A had to be an integer. So you know what I'm going to do? I'm not even going to pick 2.9. Some of you are expecting me to say, let's pick 2.9 and 9.1. No, I'm going to pick the exact borderline examples. This question is really important, so focus on this one because you really could learn something. If b is greater than 9, I'm actually going to pick 9, even though it's not allowed, just to find the borderline. If a is less than 3, I'm actually going to pick 3 because that's the borderline. 9 minus 3 is 6. Now, 6 is the borderline case. So I know I'm not allowed 6, but I'm actually allowed anything else. So for example, anything bigger than 6. How do I know bigger? Well, obviously I can make b 10, or I can make b 11 or 12. So I know it could be anything bigger than 6. But it can't be specifically 6 because 6 was the borderline case. I'm not actually allowed 9 and 3. So it could be 7, 8, 9 or 10, meaning it can't be A, it can't be 6. And notice many of you would have picked 7 because you'd have done 10 minus 2 is 8, and so the answer is you can't be 7 or 6, and then you'd have got confused or something. So really important when you're picking numbers, pick the borderline cases even if they say there has to be less than that. Okay, enough of my lecture. Obviously I'm using up time here by teaching you, but I think I'm so good at this that I can afford to use up time and still probably get them all right. Okay, let's try this. A little bit of arrogance there, I might get this wrong. Triangle ABC is inscribed in the semicircle. If the length of side AB is 10 and the length of side BC is 24, we could use Pythagoras there, what is the area of the shaded region? Well, good to know some Pythagorean triples. I believe I talked about this in one of my videos. So one of the triples I want you to memorize is 5, 12, 13. Just the more famous one, by the way, is the 3, 4, 5 Pythagorean triple, but this is also another quite important one. Why is that important? Well, 5 squared plus 12 squared does equal 13 squared, but not only that, all the multiples of these numbers also form triples. So in this case, 10, 24, and 26. So knowing these triples off by heart and knowing that the multiples of these numbers will also form Pythagorean triples, I know immediately that AC, the long side of this triangle, using Pythagoras will be 26. Didn't even have to use a calculator, didn't have to square anything or square root. So that long side is 26. Meaning that to find the shaded area, all I'm going to do is the area of the triangle, which is 10 times 24 divided by 2, which will be 120. I'm going to do the area of the circle minus the, well, area of the semicircle, I should say, minus the area of the triangle, which is 120. How to find the area of the semicircle? Well, AC is the diameter, that's 26, so the radius is 13. The area of a circle is pi r squared. That's pi times 13 squared, which you should know off by heart, is 169. Pi r squared, there you go. So 169 pi. And that is the area of the circle, right? And I'm just getting confused here because I can't see the answer that I'm looking for. Let's quickly double check that. AB is 10, BC is 24. So that means AC is definitely 26. So the radius is definitely 13. Pi times r squared, 169 pi. It's the area of the circle. So the area of the semicircle is half of that. So something like 84.5 pi. Take away 120. That should be the answer. I think they've made a mistake and they've doubled it. Instead of halving the circle, they've doubled it to get 338. Yeah, that's what they've done. Which is really bad. Obviously, they're creating this test and they can't even get their own questions right unless I've made a mistake. And I can't see that I have. The radius is definitely 13, so pi times r squared, 169 pi. That's the full circle. You would halve that, not double it. They've doubled it to get 338, but you halve it to get a semicircle and then take away the 120. So I think they're going to say it's D, but it's actually the wrong answer. Really bad, but I would say 90% of these questions are pretty good, and therefore that's why I do these videos. and they're free to everyone, which is nice. It's just a pity they make the occasional mistake, to be honest. Anyway, this one. An asteroid travels through space at a constant rate of this. If the distance between the asteroid and a certain planet is that, approximately how many seconds will it take the asteroid to reach the planet? Well, so 10.2 mil divided by 2.6 mil is about 4, right? 2.6 goes into 10.2 about 4 times, roughly. So therefore it will take 4 days, right? 2.6 million feet per day. So after 2 days, like 5.2 million. After 4 days, 10.4 million. So basically 4 days, just under 4 days. Well, 4 days, let's start approximating. In 1 minute, we've got 60 seconds. In 1 hour, we've got 3,600 seconds. Probably will have to use a calculator here. So 3,600 in 1 hour, times that by 24 for 1 day, times that by 4 for 4 days. And it's going to be just under this. Okay, well, obviously not, maybe just over, but 350 was by far the closest. So that's what I would pick. Maybe the answer's like 340 and they've just rounded it to 350, so fair enough. Probably would check that if this was the real test, but I'm pretty sure I did that right, so I'm just going to move on. Okay, next one. If 1,000 students majored in philosophy 2002, how many students majored in 2004? Well, this is the percent change, it says. So in philosophy, it went up by 11% between 2002 and 2003, and then it went down by 3% the next time. So if we started off with 1,000, how do we quickly increase by 11%? Times by 1.11. How do we quickly decrease by 3%? Times by 0.97. Should know both of those off by heart. So 1,077, which is closest to 1,078. But why do they keep rounding it? In the real test, that would freak me out, because it's like, why didn't they write 1,077? But in this test, with their kind of errors, I'm kind of not as bothered by it. Yeah, that was 2002. So there's 2 different years. So there's 2 different changes, gaining by 11% and then reducing by 3%. What you definitely don't do, the mistake here, would be to combine those two and increase it by 8%. That would actually get you a totally wrong answer. So don't make that mistake and try to combine the 2% changes. But then the weird thing is you make that mistake and you'd still pick 1,078. So it's a badly designed question. They need to have a wrong answer where if you make the mistake, that's the kind of answer you would pick. But here, even if you make a mistake, you would still pick the right answer. So, oh well, that's closest to 1,078. It still feels like I'm missing something though, like, it's such a dodgy question. Like, they should have the wrong answers be closer together. Either way. Anyway, next one. Based on the chart provided, which of the following statements must be true? The number of students who majored in psychology in 2004 was less than the number of students in 2002. Yes, because if you lose 10%, you're down to 90%. Then if you increase by 10%, you're back up to 99%. So you're still below where you originally were. You might think it balances out, but that's not how percentages work. B, the number of students who majored in 2004 in maths was more than 17% greater than in 2002. Let's check that. So let's say we started off at 100. Let's increase by 6%. And then let's increase by 11% and see if we're more than 17 above. Yes, we're 17.66 above. So that's also true. In 2004, more students majored in maths than any other subject. No, we don't know the actual numbers. These are just percentages. We don't know the actual numbers. So C is, we don't know for sure. Because again, we don't know the actual numbers, just the percent changes. So pretty confident. Next one. If the number of students who majored in biology in 2002 was double the number of students who majored in English in 2002, Okay, the number of students who majored in biology was approximately what % greater? Definitely pick numbers here to make our lives easier. So let's say they both, actually sorry, let's say that biology was 200, which is double 100 for English. Pick nice and easy numbers. So biology 200 in 2002, English 100 in 2002. So what happens to biology? It goes down by 12%, that's timesing by 0.88, and then it increases by 8%. So it's now 190.08. So let's call it 190. That was biology picking the number 200. Let's see English, and we pick the number 100 because that's half of 200. English started off at 100, and then it went down by 3%. So obviously that's going to be 97. And then it went down by 10%. So that's now 87.3. And now the question is, approximately what % greater than the number of students who majored in English? Now, very important, I've talked about this in many videos, the % greater than formula. Yes, the difference goes on top. So that's 190 minus 87.3. But the question is, what's the denominator? Do you remember? If you've been watching any of my other videos, you'd know the number that is after the word than goes at the bottom. So after the word than was the number of students who majored in English. So that's the 87.3. So divided by 87.3. And then of course times by 100. So it's 117.6% greater. Very important you know that formula about % greater than. The denominator in the formula is the term that comes after the word than. In this case, English. Okay. Population of state X is double that of state Y. Very nice. If the population concentration, people per square mile, is triple, then what is the ratio of the area of state X to the area of state Y? Wow. Definitely going to have to pick numbers here because it's a bit confusing. So we've got a population being double. Let's do 200 and 100 again. Do you notice, by the way, how often I'm picking numbers? It's like a lot, isn't it? Are you picking numbers that often? Maybe you should be. Okay, so the population is double. If the population concentration people per square mile is triple, so let's say it's 3 to 1, that's the pop per square mile. Pop per mile is triple that, so 3 to 1. What is the ratio of the area? Well, if you've got 200 people and 3 people per square mile, let's use a calculator, got 200 people and 3 people per square mile, you do 200 divided by 3, right? And that's 66 square miles, because 66.6, 66.7, because it said people per square mile, meaning there's 200 people and there's 3 people per square mile. I just made up 3, of course, because we're picking numbers, but 3 people per square mile, or 200 divided by 3, that means 66.7 square miles. This one said there's 100 people in state Y, and 1 person per square mile, meaning there is 100 miles. 100 divided by 1 is 100, so 100 miles, giving us a ratio of 66.6 to 100. Then what is the ratio of the area? But they want it as just one number. This is really important. When they want a ratio as just one number, they want you to divide it. So 66.6 divided by 100. Because obviously I can't write the ratio 3 to 2 or whatever. They actually just want it as a single number. And that's 0.66. So when they want a ratio just as a single number to input on the screen, just do the first number divided by the second number. So 66 miles divided by 100 miles gives us this as the ratio. Okay, 5 minutes left, 2 questions, should be okay. If x and y are unique non-zero integers, such that x plus y equals 0, then which of the following cannot be true? Okay, so some examples here would be 2 and minus 2. And that's it, just mirror image ones like 5 and minus 5. That's the only way to get 0, basically. Which of the following cannot be true? So A can be true, A is true. X is less than Y. Obviously, it could be the other way around, by the way, minus 6 and plus 6. So B can be true. One of them can be less than the other one, for sure. Timesing them is greater than 0. So C can't be true, because 1 will always be negative, 1 will always be positive. So when you multiply them, it will always be negative. I wouldn't check the others, obviously, because of time. Final question. You see how I don't really have that much time to go back and check my other answers. So I normally just pick an answer and move on. A used car dealer purchases used cars for the prices ranging from there to there and sells them for prices ranging from there to there. If the dealer sold 10 cars yesterday, what is the maximum profit that he could have earned on all 10 cars? So max profit would be if he bought them all for 8,000. So that's 10 times 8,000. That's the cheapest price he could have got them for, which is 80,000. That's the expenses. And the revenue, to max it out, they could have all been 18,000. That's the highest end of the range. 10 times 18,000 is 180,000, giving us a max profit of revenue minus cost, 180,000 minus 80,000 of 100,000. Okay, so obviously I've got 3 minutes left. For the purposes of this video, I'm just gonna pick this as my answer. I'm not gonna go back and check. Obviously in the real test, I would go back and check. But I know that you guys can't wait to see the answers, nor can I. So let's go through. I'm gonna very quickly, just for a minute or two, discuss like which ones are useful. This one was actually probably one of the harder ones because we factorized using the difference of two squares, but that didn't really help. So it was more just a question of noticing that you could have negatives. This question was easy, you need to know the formula. This question was much harder and you need to know the golden set. So do rewatch that part of the video if you don't know about the golden set. Positive integer, positive fraction, and negative integer. That was fine. That was fine. This was good. If Q is 1, it doesn't matter what the power is. This was fine because it's similar triangles. So interesting. Oh, they did say it was B. They did say it was B. Do you remember this question where I said it depends if Z is 0? They made a mistake. That's embarrassing for them, I think, because they never said that Z couldn't be 0. So yes, I agree that if Z is 20 and they pick this example, it ends up being this. But they didn't. So they're going to say I got that wrong. But where in this does it say that Z can't be 0? It adds 5 and then marks down the price by Z%. They said nothing about Z. And if Z is 0, watch what happens. We start off at 100. Okay. If we add 5, that's 105. And then mark down the price by 0. We're still at 105. Quantity B. We mark down by 0, so it's still at 100. Add 5, 105. Two quantities equal, so the answer is D. They've made a mistake. And I used to create questions for a living as well, so I know this kind of mistake. I don't blame them too much, but this is a mistake in the question. They're going to say I've got it wrong, but I actually haven't. They've got it wrong. That's how good I am. I'm showing their own mistakes. That's the difference of two squares. Fine. That's fine. The LAV principle, I probably should do a video on that one day. This was fine. About averages, you need to know to multiply to find the total. That was fine. That was all about picking the borderline examples. Actually, that was really one of the most valuable questions in the test, I think, for you guys. This was, they did pi times 26 squared. The diameter is 26, and so the area is pi times 13 squared. You don't do pi times diameter squared. The formula is pi r squared. That's really bad. They made a classic mistake. The formula is pi r squared for the area of a circle, not pi times diameter squared. Yes, the diameter is 26, but the radius therefore is 13. That's amateur hour. I know you could say, oh, this test is rubbish and pointless, but As you saw, 18 out of the 20 questions I think are decent. So that's 90%. Still worth doing for you guys. That was fine. That was... Ooh, did they say I got that wrong? Is this the first possible wrong answer here? Was it 1,100? Wait, 1,100? Did my calculator get that wrong? Yeah, because I was on 1100 and I did reduce it by 3% times 0.97. Did I just type that in wrong? Oh my goodness. Maybe I literally just typed that in. Or did I pick 1067? I can't remember. That was really weird. You might want to rewatch that bit. Because I remember getting 1078 or something. That's so weird. Did I just rush that on the calculator? If I did, then that's my fault. Oh no, they've made a mistake. They increased it by 10%. They multiplied it by 1.1. That's increasing it by 10%. But philosophy went up by 11%. No, I typed it in right on my calculator. And then I did 0.97, which is right. And then I got the weird answer that was closest to 1078. They're the one, because they increased it by 10%. It says in the chart it went up by 11% philosophy. Dear oh dear, these guys, man, they should check their work. Check their work. They create good topics, but then they make loads of little mistakes. This one, yes, A was correct, B was correct, C wasn't. That was fine. This one was fine. Yep, 117%. I wrote that. That was a good question, actually, because it was testing that percent greater than formula. This one, I got right, 100 over... Did they even finish that? Let me try and scroll down for you guys. That's it. They didn't even... Are they going to let me increase the screen of this? Sorry about this. Yeah, 100 over 150 is 2/3. And what is 2/3? I can't write down 2/3. It's 0.66, which is 2/3. And in the real test, they would want a single number. That's why they put a box there. Yes, if they'd given me 2 boxes, I'd have written 2/3. Dude, these guys need to figure out their interface. It's so lame. Okay. And this was... Ooh, it was indicate all that apply. Okay, finally. One question I deserve to get wrong. Obviously, if I'd had the time, I used the time to go back and check my answers, I would have maybe got this right. But finally, you guys can actually see one I genuinely got wrong because I rushed it. I said indicate all that apply, and I just picked this one and moved on. So that's a little lesson. Obviously, I was kind of taking the piss a little bit by rushing at the end, but in the real test, do double check that it's not one of those tick all that apply. So that's fair enough. And this one was fine. So do let me know in the comments if this was helpful. Obviously, it's more work on my end, but it was also quite fun. So I hope that helped.